All right, guys. For those of you who are surprised and can already tell that this is not an in class recording, well, that's what happens when you get your equipment set up. You have it all on, but you forget to start the YouTube broadcast. This is what happens is I've got to record it separately. I was thinking about saying that we actually didn't have class for those who skipped, but anyway, so this is going to be condensed compared to what we did in class, and but hopefully you still find some value in it. So we will have a brief overview, and then we'll talk about each of these four methods: quick exposure checklist, the REBA, RULA, psychophysical tables, and then we'll also do a quick review of the NIOSH lifting equation. We'll be using the revised equation. There is an earlier version that doesn't account for some of the things that the newer one does. Multifactorial methods is a fancy way of saying an assessment that includes multiple factors. And we are looking at multiple methods here. So almost a different level of multifactorial. Um, but there tend to be four primary risk factors for ergonomic musculoskeletal disorders: repetition force, awkward postures, and lack of proper recovery periods. um, I'm not going to whack my hand like I did in class, but um, if you were there, you remember that anytime you injure any of your tissues, you've done micro trauma to those tissues, and if they have time to recover, then it's no problem. Our body is great at fixing itself and getting back, on track. But if you for example, if there's a lot of repetition in your job and that repetition involves micro trauma, like Amy's example of a jackhammer, you're doing micro trauma to your hands, and that damages the capillaries and other tissues in your hands. If you're doing that all the time, then there isn't time for your hands to recover completely. And the next time you start work, your hands are still trying to get back to where they were. And then you start damaging them again. And over time, your capillaries are so damaged that they no longer function. They're not going to come back. And your fingertips go white and you might lose them. That's a syndrome called Raynaud's syndrome. Just an example of, you know, of both repetition and the recovery periods and their application. There are some other things. So vibration, mechanical forces, environmental factors, and organizational factors. So you can imagine if your work is designed so that people are paid per widget that they produce or iPhone that they assemble, then they're going to try and work faster because they want to earn more money. They're going to still be there for 8 hours or whatever their shift happens to be. But if they can produce more widgets, then they're compensated better. Uh, so you may have to rearrange the way that you compensate people to control ergonomic risk factors. Most of the most methods are multifactorial, and all the ones we will talk about are. Um, they try to capture everything that contributes to the exposure. You can look at this on your own time, but there is quite a bit of evidence supporting these risk factors for different parts of the body. So the QEC, or quick exposure checklist, is the first one we're going to cover. It is it's for multiple types of exposures and multiple body regions. Um, it can help you identify what you need to do to reduce exposure. Some of its advantages are that it is multifactorial. Um, it looks at interactions, has good sensitivity, meaning it's pretty accurate in um, identifying the actual exposures. Um, it has fairly good inter-observer reliability and high intra-observer reliability. So that's something we talked about in class. Um, is that inter-observer reliability would mean um, if Amy and Brittany both use this tool to assess a task, then with inter-observer reliability, um, it if you had good reliability, then their scores would be identical or very close to the same. With acceptable or moderate, then I would say that they're going to be slightly different most of the time. With high intra observer reliability, it means that if I use this tool all the time, then my scores aren't going to change that much. Meaning, and what I mean is, for the same task, I would generally produce the same score in my assessment. So that's what those mean. This is an example of the worksheet. You can see we're looking at the back, shoulder, wrist, and neck. um, we uh, uh, we rate each of our task in each of these areas based on a few things. So, for example, up at the top, when performing the task, is the back almost neutral, so straight up and down? Is it moderately flexed or twisted to the side, or very flexed or twisted to the side? So you would pick one of those, A1, A2, A3, and you're going to go through this and do the same for each of these questions. And again, it really is similar to a checklist. Not exactly, I'd say, but it's pretty quick, just like the name implies. Um, and fairly straightforward. The lack of figures on the worksheet makes it a little bit harder to use than, say, the Reba or Rula worksheets that I gave out in class. But you could produce a worksheet that has these figures here to help you understand what it means, for it to be almost neutral or neutral versus, somewhat flexed or excessively flexed. And you notice up there it says observer's assessment. That's because it's not entirely based on the observer and their assessment, but also the worker's assessment of their own task. And we'll get to that portion later. But there are sections here for the back movement, for manual handling, non-manual handling, for the shoulder and arm posture, and movement for the wrist hand posture and its movement. One thing, a fun fact that I pointed out is that a, a lot of people who are, and I say a lot, I mean a majority of people who sleep on their side flex their wrist quite a bit. I'd say, if we were using the verbiage of this checklist, excessively flexed, and have their hand under their face or their head. Um, and that's fine, except that if you do that a lot or your wrist is flexed excessively, then you could be doing damage to some of your soft tissues, and you could end up with something like carpal tunnel simply from sleeping. Um, so be aware that if you're a side sleeper and you do that, since learning that, I've tried to do that less and put my hand in different positions, not a flex position, but it's just interesting that somehow my subconscious, I find it comforting to have my hand right there in my face while I'm sleeping. So wrist hand movement, the neck. So you can imagine we're going to be looking at the posture of the neck there, and then the worker's assessment. So this is something that they fill out themselves, and uh, you can see some of the observer could fill out some of this, but you would have to ask the worker these questions, about frequency and duration, about the weight being handled, and the visual demand. Do they have to look at for fine details, or is this, they don't really have to squint or pay much attention visually, or how stressful it is. I mean, you're gonna have to ask if they're not filling that out themselves. Once you have all your scores, you come here and tabulate things up. Now, for me to draw, I do have to get out of the that view. Um, Let me see if I can minimize the notes and stuff. I might not be able to. Um, I just want to get this bigger. No, that doesn't help. Well, we'll do that and see if I can hide the notes. I know. Oh, there we go. Okay, helped a little bit, and that. All right. So, all right. And sorry, I want to make sure that. Well, who cares what color it is? I guess. So, I pointed out for the back that we have these values here. Um, A1, A2, A3, and we've got to compare that. Those are capital. We got to compare those values to A1, A2, A3, A4 here on the side. Each of these is sort of like an exposure matrix. So we have a bunch of little matrices here. All you do is once you've gone through the checklist, you find the location of your score here on the column headers as well as the row headers, and then find the score in the middle. And you're going to add up your scores: score one, score two, score three, all the way to the bottom. You can see here that I'll go ahead and go back here because that writing's not working very well. You can see that the total possible is 218. So once you have your score, you divide it by 218 and then multiply it by 100. You're going to get the percent of the max. And then here you can see the interpretation of your score. So if it's below or equal to 40%, that's acceptable. But as you increase and then as you get over 70%, then you need some immediate action and change that because people are at high risk. You can also see the equivalent on the Rula scale over here. And apparently, someone has gone through and compared the two to see, with the same task, what do the scores look like. Regardless, it's a fairly quick and easy way to get some scores and an idea of the risk for MSDs. For So again, some of the advantages we talked about. It has pretty good reliability for inter-observer. It has been validated by practitioners, but the I don't think it's been validated scientifically, and it only focuses on the physical workplace factors, not really maybe the psychosocial um, or others. So with Reba and Rula, if you have questions, Amy did a great job of explaining both, but we'll go through them briefly here. It's the same idea as the QEC, it's just a little different. And I'm actually, for this portion, going to just pull up the worksheet that we had in class. Let's, sorry, get this to full screen. All right, so I think looking at the sheet and using it gives you the best idea of what it's actually all about. So with Reba, we care about the entire body, as it mentions. We're looking from the head all the way down to the legs, at least. Um, we don't necessarily look so much at at feet and ankles, but that's okay. So you're going to be interested in the neck position. Do they have to tilt their head forward or backwards? Looking at the trunk position, how much are they leaning over to do this job? And look at their legs. Are their knees bent? Are they standing up straight? Um, Also look at the load. How heavy is the lift? Um, Once you have those values, you'll find these scores. So you'll add up a trunk score, a leg score, and then you'll find this score A. Once you have those, then you can come up to this table here, and you see you have neck, trunk, and legs. So let's say that we had a neck score that was 2, a leg score that was 3. So I find the 2 for the neck, 3 for the legs, and then my trunk posture score was a 2. So I'm going to come down here to a 5. So I've got a 5, and then I can come here and look at this little blue table to see how that compares and what the risk is. So it says medium risk, investigate it further and change it soon. So it means I have time to look into it more and figure out what exactly I need. You can see if you have greater than 11, then oh, sorry, we don't use this table till the very end. So forget that. It's been a little bit since I used this one. So we will get a score for table A, and you can write that score down here. So that's your score A. Now we're going to do the arm and wrist. So we analyze the upper arm position, we look at the lower arm position, and then the wrist position. We're going to get scores for each of those. Then we use table B to find our score. So let's say, so for score A, we've got 5. For table B, let's say we do this and we end up with a 7. Um, so let's say we have lower arm 1, wrist 3, or wrist uh, 1, and upper arm 5. We're going to end up on this 7 here. So that is our score B. With those two together, now we can find a rebus score, but we do need to, uh, excuse me, before we enter our B anywhere, we're going to add in our coupling. And we'll talk more about this with the NIOSH lifting equation, but that's basically how much grip, how much of a handle can you get on the load. So if it's got handles, that's good. You can see that means you don't add anything. But if it's bad, like a really awkward object, then you're gonna add 3 here. So you get your score B, you add to the coupling. That was the posture score B. You get your final score B, and then you use this table to estimate a table C score. Um, so we had, let's see, we had a 7, but let's say we have fair coupling, so we're going to end up with an 8 for our score B. We've got 8, and we've got, I forgot what we said, I think we had a 5. So we've got 13, or sorry, 8 for score B and 5 for score A. So that gives us an 8 for our score C. I keep wanting to add those together, but we don't. We use table C to find our table C score. We ended up with 8. And now we have to figure out what our activity score is. So here we're looking to see if one or more body parts are held for longer than 1 minute. If it's a repeated small range of actions, more than 4 times per minute, and if it causes a large range change in postures. So for any of these, we're going to add points. So we're at an 8. Let's say we've got one of these, so we add one, and we're ending up with a 9 for our REBA score. And that is high risk. It means we need to investigate and go ahead and implement a change, immediately or as soon as we can. Rula is similar, but you'll notice that it does not include the lower body. It's focused all on the upper body. What it stands for is the Rapid Upper Limb Assessment. So we're just concerned about the upper body, and it's a similar process. And I apologize for my little tangents on Reba, but it is pretty straightforward if you just take a second to read it and pay attention. Um, and the figures on this worksheet are nice. They really do help to figure to make guesses and do and get a decent estimate. but you're going to use the same sort of process here, finding scores using the tables uh, as a sort of risk matrix to find an updated score. Put those together, and then you'll get a RULA score. Um, so again, similar process, but focused mostly on the upper body. This is an older example, or just a different example of the REBA scoring sheet. That the company that I got that REBA from is they made sure to squish it down onto a single page. And you can imagine if something is more than one page, people are less likely to use it or complete it all the way. This is an example of posture for someone who's handling a patient. This is a huge issue that we didn't talk about in class for nurses and healthcare practitioners, patient handling, because it's a task that's really difficult to automate. We haven't figured out really good ways of moving people without using people, and it tends to be a big source of injuries in the healthcare industry. It actually, I think there are so many injuries that it has injury rates that are higher than some other high risk industries like mining, for example. I'm not sure uh, if that comparison is true, but the injury rates in healthcare are much higher than you might expect. This is an example of the RULA, just a different different worksheet and an explanation for how to do that. All right, so the psychophysical tables are sometimes called the Snook tables because of the researcher who applied psychophysics to ergonomics, and that was at the time that was a new thing, never had been done, so that's why they attach Snook's name to the table sometimes. Um, so these tables, again, a similar idea, but a different approach. And these, one of the advantages of the psychophysical tables is the amount of research that went into, and the type of research that went into producing these. So I'm not going to talk much about the experiments, but you can look at that if you'd like. Uh, Apparently, these were well done, and again, that's one of the strengths of the tables. A few limitations. So the experiments assumed an 8-hour shift, or at least no more than an 8-hour shift. So if you are assessing someone whose shift is longer than that, then you're in trouble. It will exceed the criteria. Weights in the tables that are italicized exceed criteria. And if you have combined tasks that involve several other tasks, then it will exceed the criteria. Some of the advantages is that it is based off of fairly realistic simulations of industrial work and looks at intermittent and rapid material handling. The results are reproducible, but it relies a lot on subjectivity. And to be honest, all the tools that we're looking uh, at least so far, are somewhat subjective. You could measure these values, but that there is a certain level of subjectivity inherent in each of these tools. A little bit less so with the NIOSH lifting equation, but the others, Reba, Rula, and the QEC, there's subjectivity involved, and that makes it hard to be reproducible. Um, if you have high repetition, you're going to exceed criteria, and it is not for asymmetric tasks. So we are interested in the width of the box, the vertical distance of the lift, the range of the lift, and the frequency of the lift with these uh, psychophysical tables. So here's an example. And in class, we used females because They made up the majority of class, and we'll do the same here. So you need to find the width of your box. Now, if you know if it doesn't happen to be exactly 75 centimeters wide, then you're going to have to use some judgment here. This is some of that subjectivity. I would suggest that you go with where you're closer to. So if it's 53 centimeters, then I would go ahead and go with 49. What if it's not clearly closer to one or the other, say 75 to 49? I would choose the width that results in the most conservative and the safest value. So in this case, we would go with a wider box to result in a more conservative number generally. So let's say we pick 75 centimeters and or more, uh, and the vertical lift distance, let's say it's closest to 51 centimeters. Now, the percent of the industrial population. So, if I say that I have designed a sit stand workstation that will accommodate 90% of the population, it could be that I'm excluding the Shaquille O'Neals of the world. And if you're really tall, it's just not going to work for you. Or it could be, so that's the upper 10% in terms of height. Or it could be I'm excluding the lower 10%. So the 4 foot nothing people. Um, if you've ever heard the song, short people got no reason to live. It's an interesting song, but anyway, I don't know why. I just thought of that. It's funny, obviously sarcastic song. Um, that I don't. I mean, you know. Anyway, um, don't worry about that song. So, um, so if this is where you really have to understand the demographics of your worker population. If you have, if you want to design for as many people as possible while you're using these tables, you're going to look at the 90th percentile. And I would say look at the 90th percentile on the female table. Um, and that means that almost anybody that gets employed at your site should be able to handle this lift. Um, if you're in an industry where you don't really have much variation and it's all Olympic weightlifters, then maybe maybe you can use the table for males, and you could design the task for the 10th percentile or 25th percentile of males, and you'll still be okay. So again, this is where some of that subjectivity comes in and professional judgment. You've got to decide. All right, so once you've got that, then you've got to decide what the range is for this lift. Are you lifting from the floor to, about your waist, from your waist to your shoulders, or your shoulders to your arms reach? Pick which type of lift, and then look at the frequency. So is this once every 5 seconds? Is this once every 8 hours? And then everything in between there, you can see. Um, you've got up to 14 seconds, or once every minute, 2 minutes, 5 minutes, or 30 minutes, or once every 8 hours. So those are kind of the options there. You select that, and then you follow that down, that column down, to to pick your number basically. So if I was, let's say I had a width of 75, a vertical distance of 51, and I want to design this for anybody. Let's say, this is retail, and I have a whole range of people, everyone from, I mean, I'm thinking of like Walmart. I've got 7-year-old people working, and I've got 18-year-olds as well in great shape that lift weights. So I want to design this task for all of them in mind, so that they can all do it. So what I would do is use the female table. Um, so and so I'm going to go for 90th percentile here. let's say this is from the floor, and this is a lift that they do once every 5 minutes. So I'm gonna follow. Hopefully you can see my arrow, but I'm at the 5. I'm gonna follow down to the 90th percentile row in the 51 centimeter vertical distance box within the width of 75, and I get a 9. So that's 9 kilograms should be the max weight that I have these people lift once every 5 minutes. Uh, Assuming that this is going up to, but not exceeding 8 hours. So you can see the first two tables are for lifts. These are for lowers, lowering, and there are also tables for pushing and pulling, and we care about the hand height, the distance of push, and the frequency of the push. So we'd use these in a similar way. I'm not going to walk through it this time, but well, after you look at it for long enough, then you kind of get the idea, and you can figure it out. And we also have one for carrying. We're interested in the height of the hands from the floor, distance of the carry, and the frequency. And again, this is for 8 hours. Um, Again, I'll let you look at that. I won't walk through it, but if you take the time to look at it long enough, then you figure out what you need to do. All right. So for the NIOSH lifting equation, you've already covered that, but we are going to review it here. Now, actually, before we get going into that, I wanted to show you the NIOSH lifting equation app. You can get it for both iPhone and Android, and the icon kind of looks like that. There, it's published by the CDC. It's really by NIOSH, which is part of the CDC, and your home screen in the app kind of looks like this. Sorry for the poor resolution. Um, and when you open it up, you get this sort of a view. I will refer back to this because there are a couple of things here that are a little bit different. Um, and from the lifting equation, if you were to do this by hand or in Excel, just a quirk of the app, I guess. So we will go back to that in just a minute, but you can see some of the history of it. The output is the recommended weight limit. So that's what we're interested in, but we need to compare that to the weight that we are using in reality. And this is designed so that most people could perform this without increasing the risk of low back pain. So that tells you right there what kind of lift this is targeting. It has a sort of narrow range. You can see here, it's not for one-handed; it's for two-handed. It's not if you're over 8 hours and all these other things. It doesn't include carrying, pushing, or pulling. Um, Unstable objects. It doesn't work for shoveling or pushing a wheelbarrow. Uh, so, um, yeah, somewhat limited range. You see here at the top, this is our primary equation to get our recommended weight limit. And each of these terms represents another equation except for the load constant and these two values from the tables. But for the horizontal multiplier, vertical multiplier, distance multiplier, and asymmetric multiplier, we have to plug in a number into an equation to then use it in this larger equation. If you're doing this by hand, it really is helpful to just break everything out and do each one by one and keep track of all your variables. Keep everything separated until you're ready to put it all together. With the app, you don't have to worry quite so much with that. All right, so H is the horizontal distance of the hands away from the midpoint of the ankle. So that's the hands um, on the box or on the load. And you can see, yeah, so it is possible to pick something that's in inches or centimeters. And this table here will tell you, so you don't have to do the equation. It tells you what it is uh, without doing that. Um, Anyway, but you'll measure that distance and then you'll plug it into this equation up here, either 25 divided by h or 10 divided by h. And um, so that's h. That's all there is to it for that one. For vertical distance, so v is the vertical location, the distance of the hands above the floor at the origin and destination. So you could um, this is where the app is a little bit different for both horizontal and vertical. So generally, you may pick this up, and if you're moving straight up, kind of like this figure depicts, then the horizontal distance isn't really going to change. It's staying relative to the center of the ankles. It's not really moving out or in. It's the same. But if you're lifting, the vertical location should change. So you may, I mean, if your hands are on the floor, I guess you could say that you start at 0 and you're going to lift up to 30 inches. Um, that would be a difference of 30 inches there. If and So we can, let's go over to the image from the app just to see what it looks like there. So it may be hard to see, but for the horizontal, they have 23 and 23. So they didn't weren't extending their arms out or bringing them in any closer. This is just a straight up lift compared to the body, relative to the body. But for the origin, they say that they're starting 15 inches or centimeters off the ground and lifting to 63. I'm guessing these are centimeters just because the numbers are this large, but um, so they were 15 centimeters to begin with and lifted up to 63. Um, what I usually do, and I guess I don't think about it, is I just calculate that difference automatically, and then that is V. But in the app, you put both, and it will then take the difference. So if this was 13 and that was 63, then we'd have, I'm just making the math easier, but then we'd have 50 centimeters as our V. Here, I guess we have 48 centimeters for our V value. And for asymmetry, you can also do the same thing if they're remaining twisted during the lift, or they, for example, they may be pivoting from facing to the right all the way over to facing to the left, and that's where this is helpful. Is you determine the extent of that twist in degrees. Um, but we'll go back um, to our slides here. The distance is, I can go back to the figure, the distance that the box is lifted vertically. So you can imagine often this will be the same as V. Uh, and I mean, a lot of times it will be, but it's the absolute value of the difference in vertical heights. So you could do it for lowering as well, and not get a negative number. So for the asymmetry multiplier, you're looking at the angle of movement of the load from the mid sagittal plane. And it could be that this load is moved from the right side over to the left. And in that case, the degrees is going to be larger than, 90, or, yeah, it may be substantially larger angle, and that's going to affect the recommended weight limit quite a bit. For the frequency multiplier, you simply use this table. You've got to look at the duration of the job. Is this something that they do 4 8 hours a day, or is it just 30 minutes a day that they do this? And then also look at the frequency of the lifts. How many times per minute are they doing the lift while they're doing this task? You can imagine if you're unloading a pallet, sometimes they get pretty high on the frequency of lifts when unloading pallets, and that's you know you can see down here that there's lots of zeros, and if you put a 0 as your frequency multiplier into that larger equation, you're going to get 0. So that can have a large effect um, on what you get for your recommended weight limit. And this is something that was not included in the original NIOSH lifting equation. They were not considering, they were looking at biomechanics only, and didn't really give much weight to the physiology of it. But we know both are important, and it's important to have measures from each. And so it's good to have this table in here, or this term in the equation. And then the coupling multiplier, again, how easy is it to grab and grip the load. If this is a box with handles, that's good. If it's a 90-degree angle box where you can flex your hands 90 degrees around the edges, then that's fair. And then I think of a mattress or something really weird and awkward, that's going to be poor coupling. So you figure out which type of coupling you've got, and then depending on what your V was, you're going to select a value, from this table. After you've calculated your recommended weight limit, you're going to compare it to the actual load that you are lifting. So um, if you get a recommended weight limit of um, let's say 15 pounds, and the load weight that you are lifting is 30 pounds, then you're going to get a lifting index of 2. And as this shows, anything over 1 implies increased risk. So you want to try and keep it below 1. And just to show you an example of the output from that app, so after you've entered these, so you can see you enter the 2 angles. If there is any twisting involved with the lift, you enter the load weight. So this is where the index will come into play. The frequency, and the app helps you to select one there. The duration, is this for up to 1 hour, 1 to 2 hours, or 2 to 8 hours? And then the coupling is a good, fair, poor. After you've entered that information in, then it will calculate the lifting index for you. And in this case, in their example, they have a lifting index of 3.1, which means the worker's at pretty high risk for developing lower back pain, which, if you look at the numbers, is a huge contributor to workers' compensation claims, days missed and reduced missed work, and reduced productivity. So it's all about the lower back sometimes, to be honest. Um, this is an example of a worksheet for the lifting equation. Again, you can use the app if you'd like. And on Thursday, we'll go through the multifactorial lab. So we will take some measurements for everyone doing a lift like this, and compare, or a task, and compare. Um, for the assignment, you'll be comparing the different methods, uh, many of the methods that we've talked about today. And in fact, I think all of them. So, so be ready. Thanks, guys.